Now basically let's move on to our final section of the presentation, which is TCRs with BigchainDB. So by this time we have seen that the TCRs are primarily lists driven by community using curation functions, and they are supported by some parameters. We also saw that BigchainDB transaction has a JSON object as an asset, and this asset can be created by importing the driver inside the D app. So combining all of these things, let's basically build a TCR on how it looks like. So the primary concept that we want to look at here is that everything is an asset, a data asset in BigchainDB. So we have modeled the registry, the token, the curation functions, or the output of the curation functions and parameters, everything as a BigchainDB asset. So for example, and I will show you this in the code that I will be presenting, but what we are looking at is everything is encapsulated as a JSON object, and it is being stored on BigchainDB, and these assets are linked together with each other to create the entire application state. So this is how it looks like. So we have on the far right side of the slide, we have the TCR asset in itself, which has its own asset ID in BigchainDB, which is unique. We will be linking proposals, parameters, and tokens with this particular TCR because they are directly connected to the TCR, because if a proposal becomes eventually a listing, then it is on the TCR. So, and then we have parameters which are driving this particular TCR, and then we have the token, which is basically contributing towards the stake. So this is the, and then finally we have challenges and votes as assets. They are linking to their respective proposals, because you will be challenging or voting in context of a particular proposal and not in context of the entire TCR. So that's how they are basically linked with their proposal, and rest of the things are listed directly with the TCR. So this is basically the asset hierarchy that we have for implementing a TCR on BigchainDB. Let's get to the code. So I will take a moment in actually mirroring my displays, because I will be working over here and you will be seeing it over here. So give me a moment. Cool. So what we have here at the root level is a simple Node.js application, and I have created this as a library so that it can be consumed by any JavaScript application as such. I was actually planning to build an UI also on top of this, but couldn't have enough time. I tried to do a CLI with commander.js, still couldn't finish it. So now I'm just presenting the library, but the tests are completely there and it works as expected. So what we have here is a simple JavaScript application, a library code, which we have the primary functions of the TCR inside the lib folder, and everything else is basically supporting this particular functionality. So I will go to that once I reach those points. But the primary focus of this structure, or the directory structure, or the code is the lib folder where I put all the logic with respect to the TCR. So how we start with this is we have the bootstrap.js module, which has a simple function called init. What it is doing is it is actually creating that big TCR asset that you saw in the previous slide. It is writing an asset on BigchainDB with the passphrase is basically we are generating keys using a BIP39 mnemonic. I always fail to pronounce it properly, but a simple string which generates keys. We are using giving a namespace to our TCR. It is actually going inside the TCR asset as a string itself, as a property. But we are, let's call it a list for good hotels in Berlin, a list for something or something, but we want to give it a name because what we are doing is a generalized implementation. We have a token symbol because we want to generate a token for this TCR as well. And finally, we have a config state. So this is how a config looks like. Basically, this again has the same parameters that we discussed in the TCR parameter section. This has a minimum deposit, I have actually added a minimum deposit for vote as well. I'm not sure it was there in Mike's implementation or Mike's paper, but I thought the minimum deposit for vote should be less than the minimum deposit for listings. Or maybe I'm missing something over there, but I added another parameter called minimum deposit for vote. Then we have apply stage length. This generally should be epoch time or block heights, but here just for simplicity I put it in days. So you have 5 days for challenging something and 5 days for committing something, 5 days for voting on something if it is challenged. Then once we go inside this function, what we are doing is we are first of all minting a token. So there is a concept of divisible assets in BigchainDB where you can actually assign a particular amount on an asset, and then you can distribute this amount to other users or other public keys in the system. So what we do is when we create this token, actually we are calling this create token function, which is there inside my BigchainDB wrapper module. What I'm doing here is I'm actually creating a simple BigchainDB asset, but with a specified amount. I mean, I hard coded it to 21 million, and you know why, but you can have any amount basically here. And then simply it writes this particular asset on BigchainDB server with the owner being the person who has created it. So in the beginning, when the TCR is being created, you have one owner who is creating the TCR asset, the TCR token, and the TCR config. And this is exactly the same as the smart contract owner when you are putting it on Ethereum. So you have we will be primarily creating these 3 assets. First is the token asset, then we have the configuration asset, and then we have the TCR asset. And again, the namespace goes in the TCR asset with its token ID and configuration. So when we are doing the proposal and voting and challenging, we can easily query these tokens and configuration assets from the system. One more thing if you to point out here is that all of these assets have a timestamp in themselves. I mean, putting client-side timestamps is not something really good in blockchain, but we have still done that just to calculate the minimum, the commit stage length and the apply stage length, because we will be then adding the number of milliseconds for those particular days, and we will be calculating during the time when we are finalizing a proposal based on votes and challenges. So for simplicity, we have put it like this, but in a real system, please don't do that. Once this function is called, our TCR is bootstrapped. By bootstrapping means that we have created primarily 3 assets in the system: the TCR itself, the configuration parameters, and the token. So now we are basically good to go and use this TCR, because we can primarily play around with adding proposals, challenging them, and voting on them. But there is one primary thing missing over here. While we have these things in the system, there is no other user currently holding any tokens. These all 21 million tokens are actually with the person who has created this. So this is now the ICO thing comes into picture, where you want to sell those tokens. So for that, we have written a simple function called transfer of tokens. So you can simply take public key and you can transfer some of these tokens to a different user. So it also takes amount, and then it basically subtracts that amount from the person who is holding it, and gives that particular amount to the person who is represented by the public key parameter. And in BigchainDB, we follow the same UTXO model as in Bitcoin. So how this function is being written is that the person who is holding all the tokens is creating a transaction with 2 outputs. One output goes to the user who is asking for these tokens and who wants these tokens, and the second output goes back to the person who is holding the tokens in the first place, because that's how you have to spend the entire output and then generate new outputs from it when you are doing a transaction. That's how generally UTXOs work. So we have followed the same model in BigchainDB. So that's how this function is also written, that you are first doing a query on this particular token ID, you are getting the amount, and then you are checking if that particular amount sums up to this particular amount which you are going to give. If not, it will throw an error that you do not have enough balance. And if it passes through that check, then you transfer that money and rest of it comes back to you. So after the bootstrap of the TCR, we will be calling this token transfer function to give tokens to people who want to participate in the system. And when I'll show you the tests of this, I'll explain the entire process line by line on what we are doing. But this is particularly for transfer of tokens. And then I have another function over here for getting a balance. So when you are looking at putting a UI on top of this application, you want to put that cool integer control over there, what's your wallet balance and stuff like that. So you can directly call it using the public key of the user who is using the application and the token ID of the TCR where you are connecting it, and it will give you the balance. And again, it will combine all the unspent outputs of this public key and give you a combined result. It will not just query one output or others. It's basically written in that way. So once we bootstrap, we can then look at the curation side of it. So we again, like the previous slide which I showed about building TCRs, that everything is an asset. So our curation functions over here are also actually just creating assets on BigchainDB. So it will first, when you are trying to propose something or you want to apply for a listing, first of all, we will look at the config values of a particular TCR, because when you apply for something, you already know which TCR you are applying for. So you will be passing the TCR ID, or TCR ID can be taken up from the environmental files as well. I put that for simplicity over there. But you will be first looking at the configuration values of this TCR and finding out whether the amount being passed by this user is more than the amount for minimum deposit or not. So that's the first check that you are going to do when you are creating a proposal. If it passes, you transfer that amount to the passphrase or the public key of the TCR itself. So we are representing the TCR, or you can call it the owner of the smart contract or the smart contract itself, which is basically representing the TCR. But you have to stake your tokens. Where will you put it? So there needs to be some place where you are actually sending your tokens when you are trying to do something with respect to curation or applications. So we are sending it to a predefined public key called the TCR public key. So, and yes, you are right, the private key holder of this particular TCR public key has all the tokens for that moment. So we will then, after the transfer, we are simply creating a simple asset with its own timestamp, and then we are just writing it down on BigchainDB. So it's as simple as creating a new asset with some details around it and checking that the value passed or the amount passed for staking is more than the minimum deposit or not. So that creates a proposal for us in the system, and now it is in the apply stage. Basically, you have applied for a listing inside the TCR, and the timer starts from here. Basically, if you do not challenge it before the apply stage length, then it is accepted. So then comes the challenge part of it. So when you are challenging a proposal, you will already be knowing its proposal ID, because that's the asset being represented in BigchainDB. So you will be passing the proposal ID and the stake amount for this particular challenge. And we are by default taking the passphrase parameter in all of these functions, because you will be needing your keys to sign all these transactions. So first of all, we will verify that it is a real proposal or not, the one which is being passed. Then we'll be verifying that if it is already being challenged or not. So there is a more important thing, that for a proposal, there should be only one challenge at a time. You cannot have multiple challenges, because otherwise people will be confused on where to vote. So you first need to check that it is already challenged or not. Then you will be checking for configuration values, whether the deadline for challenges has passed or not. So this is where I'm actually doing the calculation for for milliseconds to days, because the timestamp is in milliseconds, and then I'm converting them into days to basically compare it with the configuration values. And then after all these checks have passed, I will be again transferring my token or the stake to the TCR public key to put my stake behind my challenge. So, and then once the transfer completes using the same transfer function which we have been using, we create the challenge asset. The challenge asset will have the stake transfer transaction also for reference. It has the proposal for which it is the challenge is being made, and if you are not putting, then you will not be able to link a challenge with a proposal. So this goes back to the slide where I was showing the asset linking, or the asset connecting assets connecting with each other. So how we are connecting these assets. So if you remember that there were challenges and votes being linked to their particular proposal. So this is how we are actually linking it, because once the data being written inside a BigchainDB asset, it cannot be changed or deleted. So if we put the proposal ID over here, we are pretty sure that the challenge will have the proposal ID forever. So we create the challenge asset, and exactly on same lines, actually, once the challenge has been created, we create the vote assets as well. So again, the same checks are coming into the picture. One important check that comes here, instead of the apply stage length, we are checking for commit stage length, because the apply stage length is now redundant because the challenge has been already made. Now from the time when the challenge has been made to the time until the commit stage length completes, you can actually vote. So before committing a vote, we will be checking that the commit stage length has been completed or not. And the same set of challenges go into the same set of checks go into creating a vote as well. You will be first checking whether there is a challenge or not, because if there is no challenge, then there is no point in voting actually. So if there is no challenge, you will just say that you don't have to vote. Then you will be looking at the commit stage length in this check. And finally, one more important thing is the vote needs to be binary. It should be 0 or 1. It cannot be any other value. So when you are passing the vote value, you are just saying that 0 means I am supporting the challenge. The item should not be on the list. And 1 means I am supporting the item. It should be on the list. So we are doing that particular check over here. And then once all these checks have passed, we transfer the stake to the TCR and then create the vote asset. So this is the overall curation functions, how they are being implemented using JavaScript for BigchainDB. We are basically creating a set of assets and linking them together. So this is exactly the code representation of my previous slide.
And how do you tackle collusion in voting? So say I'm and 3 of my best friends are big token holders, and we want to push people out of these lists, and we are always going to vote as a group basically, and since we can put more tokens behind our votes,
yes,
we can always sort of capture that.
That's a real challenge actually. So that's exactly what I think we were talking previously also, that this is a challenge that if you collude, if you are coming together as a vote, then it's either that you will lose your votes, or you will lose your stake, or else you will win it big time. So it's going to be either of those scenarios, but definitely this is a real challenge in a TCR scenario.
But I think the feedback mechanism there is, if you're a big token holder and you do anything that degrades the quality of the list, then you're degrading the value of the tokens for the consumers of the list, so you're damaging your own stake, right? If you have a majority stake in the list, then your incentive is to make sure that it has the highest quality results that it can, so people will want your list.
Okay, so every list has its own token basically.
Yes. That's what the primary concept around it is. Every list has its own interesting token.
And there's going to be a secondary market for all of them. Or how do I get tokens of one particular list?
Yeah, it has to be listed on an exchange. Yeah. All of the sub tokens have to be listed so that they can be tradable.
Yeah.
But then you also have like these other mechanisms like funding curves, which are market makers, where you wouldn't have the need for this engineering.
So moving on, like now that we have seen that we created the TCR and its parameters and configuration and token, then we transferred some of those tokens to potential curators and applicants. then some of them applied for listings, and some of them challenged them, and some of them voted. So that is all being covered in these functions which I've covered till now. But after the apply stage length and the commit stage length has passed, what's next? How will you make sure that this proposal actually is listed on the TCR or not? I mean, when you implement it for Ethereum, it's basically how it might work. I actually don't exactly remember the code in the AtChain smart contract, but something is like you change a value or a Boolean value against a particular listing, and it is whitelisted. But in case of BigchainDB, you do not have a smart contract. You are only playing with data at rest. And that is the reason we have written all of these validation logics inside the client side, because the server side cannot have this logic because of lack of smart contracts. So how will you make sure that once this apply stage length or the commit stage length has passed, you need to go back and make sure that the TCR actually has this something whitelisted or not. So for that, we write another asset. So like I said, everything is an asset. So we created another asset of called completion or result or something. So what we are doing here is inside the Finalizer module, we have a simple function called complete proposal. What it does stepwise is that first of all, it validates whether there is a proposal or not with that proposal ID. It gets the challenge. If there is a challenge, then it gets all the votes and does the stake transfer mechanics. So based on your particular amount that you have staked, you will be getting that in return, and I will come back to that. And if there is a no challenge, then it just writes the asset that this particular proposal is whitelisted. So how that happens is, over here I have this simple check that if there is a challenge, call a function, and if there is no challenge, then call a different function. So what these functions are actually doing is, first of all, what we have here is called, before that actually I need to cover one more thing which is more important here, that this particular function, the complete proposal function, can be called only by the owner of the private keys who has created the TCR in the first place. So there is this authority or entity in the system which is the you can say the caretaker of the entire system, and this might work very well in a company scenario where you have multiple departments voting and collaborating on a data governance process, where the office of the CEO is actually the caretaker of the entire thing. So this is where we are doing this check that the TCR asset that we created, the owner of that particular TCR asset is also calling this particular function. If he is not calling, then there is an access denied error thrown out of it. So now going back to the proposal and no proposal scenario, what we do here is that when there is no challenge, when there is no need of calculating the stake and putting those doing those calculations, what we simply do is we create a new asset. This asset is called a completion asset, and it says that the proposal, it just adds the proposal ID inside this particular asset. So once this asset is written on the blockchain, the way we will be querying it is, this is a proposal ID. Let me get the completion assets. Let me see if any of the completion assets has a proposal, has this proposal ID or not. If a completion asset which is being signed by the owner of the TCR has the proposal ID, that means the proposal is whitelisted. So you are basically changing the state of something by writing something new on the blockchain. Then similarly, when there is a challenge to the proposal, then we basically first of all check whether the commit stage length has passed or not. Because if the commit stage length has not passed, then we will throw an error because people still want to vote on this thing. Then basically we will be doing distribution of stake. So we will be looking, querying all the votes for this proposal. And as you remember from my previous slide, again, the votes are all linked to the particular proposal, which is the listing in the system. And then basically these, once we query all these votes, we will be looking at what is the amount of stake that has been put behind these votes. and we'll be doing this calculation, combining all that amount, and then finally calculating for every person who has voted, calculating the win amount for that particular person or for that particular public key. So, and then we will be giving it back to them because they are on the winning side. If the proposal is accepted, then these are the people who voted 1. If the proposal is not whitelisted, then these are the people who voted 0. So they will be getting back in proportion to what they basically gave to the system or they put on stake. And finally, after this, we will be writing the completion asset for this particular proposal as well. So over here. So once the stake distribution is completed, we will be saying write a completion asset with this proposal ID. And to show that this proposal was different from a no challenge proposal, we'll also put the challenge ID as well over here. So the next time when you load the TCR, it will be querying for completed proposals in this way. And then you will be basically seeing a list where proposals are in the apply stage and proposals are in the committed stage. And if this asset is not being written, that means the proposal never reached the whitelisted stage. It was rejected. So if there is no completion asset for a proposal, then mean it is rejected or in apply stage. It is not still part of the TCR. So that's basically how we have like implemented this the whole proposed challenge vote and complete scenario of a TCR. What we have is if I would like to go through one of the tests that there are tests written for positive and negative scenarios to check these checks that we have made, the apply stage length and the minimum stake and the stuff like that. But if we go on like a simple test, which is basically the positive test about completing a particular proposal, what we are looking at here is, first of all, we have created the TCR. We have bootstrapped a new TCR with its own token and configuration values. And for testing purposes, we are using actually 10 seconds as apply stage length and commit stage length. So when I'm actually creating a TCR for test, this is basically my apply stage length and commit stage length, so that the test completes within seconds. Then we have, first of all, we will be setting these process parameters, because internally all the functions in the library are actually reading the parameters from here. Then we create some new users in the system and give them 100,000 tokens each, so that they can actually come in and propose and vote and challenge the proposals. So these are the token transfer functions that I explained earlier, that how once you have created the TCR, you might want to give some tokens to people who want to use this TCR or curate this TCR. Then once the TCR is created and some of the users have tokens, then first of all, the user, one of the users actually calls the propose function and puts a proposal inside the system. The other user comes in and challenges that particular proposal using the same function that we saw for challenges. Then the user says that, oh, okay, somebody has challenged my proposal. I need to put more stake to support my cause. So he votes, comes back and votes on this particular proposal again. And the user 2 says, okay, fine, I will also put some more stake over here. So then the voting actually happens in this way. And as you can see, the amount that we have put here is the minimum stake was 100. So we have used 100 as the minimum stake here, or the stake behind the proposal. Now, the more important part is the challenge. When you are challenging something or challenging a proposal which is there, it should be at least equal to or greater than the stake put behind the proposal. So we have put the equal stake on challenge as well.
But you can define.
Yes.
Like you can set it has to be minimum, let's say 5 times.
Yes, yes, you can define it as well. If you introduce another side minimum stake for challenges, then you can define it from there. Then the first user who voted was voted with 20 tokens, and the second user who voted 0 voted with 10 tokens. So we see a clear majority over here that the person who is actually supporting the proposal, or who has proposed in the first place and then he is supporting, has more stake backing his claim, and the person who has challenged the proposal and voted 0 for this proposal has less stake, 120 versus 110. So then we will be basically calling the finalize function, and I'm putting a simple sleep over here because, as you know, my configuration values have 10 seconds of apply stage length and commit stage length. So I'm putting it on sleep for 20 seconds so that the finalize function doesn't cause a problem, because then it will throw me an error that the timeline has not been reached for finalizing a proposal. And then finally, I call the complete proposal function with this particular proposal ID. And I make sure that there is a completion asset being created because this proposal has been accepted or whitelisted as per the voting stake put behind the votes and challenges. And that's basically the overall flow of this.
From what I see and understand is that at the end of the day, it boils down to having more tokens. So people who have, or let's say, a person or a group of people who stake a larger number of tokens, they would be seeing something through. So let's say they would be voting for something or against something, so according to their opinion. So how does it, like in the bigger picture, what is the bigger benefit that it is offering?
So the bigger benefit
here also, like, it's, let's say, money power, token power playing, and in the world outside blockchains, it's something else which is decided. So yes, basically not greens.
The primary minor difference, I would say, not exactly completely solving this problem, but the minor difference is, I will come back to the point which actually Zach mentioned a few minutes ago, is that when you are playing fair, you are actually increasing the value of the token and you are getting more returns on that. If you are not playing fair, then the TCR contents are going to a less valuable state or less relevant state, and then your tokens are actually losing value. So if you are holding something, you might always work towards increasing their value and not work towards pushing people out of the TCR.
Yes, but if I take an example of, let's say, turning Wikipedia pages into token curated registries, that's often a matter of opinion in a lot of cases. So how do you define creating value?
So I would say that basically in that case there can be a new TCR which says fake Wikipedia curators, and I'll put your name on that basically, or somebody who is doing that, and then looking at Wikipedia, I would say, okay, if this guy has made an edit, I might not read this, I might read something else. But I know that there are concerns with respect to and when you have a lot of tokens, you might want to mold the system, but there are actually some checks in place which are motivating you to play fair so that you get more value of your tokens and not play towards actually hacking the system.
I think the bigger risk, and this comes in with like I think most crypto economies, is the assumption that the amount of profit you stand to make by playing fair within the system isn't overwhelmed by some external benefit to torpedoing the list, right? So like, if I have a list of like honest governments, right, and say the United States gets kicked off that list, well, compared to the GDP of the United States, buying all of your tokens and torpedoing your list is a drop in the bucket, right? So you assume that like the entire economic system world lives within this token economy, and it doesn't.
Well, you also assume that you can define what is an honest government.
Well, I'm picking an entity that has access to a large amount of wealth compared to a TCR, right? Yeah, I mean, pick whatever you like, but if you have, corporations with less than X carbon footprint, right? That's well defined. But if I'm a corporation with a large carbon footprint that makes a tremendous amount of money, it might be worth it to me to get myself off of that list by just buying a large stake in your list, right? So yeah. Anyway.
All right. Any questions? Well, thank you so much.
I got a question actually. And apologies for walking in late. I had trouble getting here. Whatever. But it's a really cool project, man. And I was kind of curious. So I mean, couldn't I what stops someone from just like making a key and saying like, hey, like the Mona Lisa's mine? You know what I mean? Like, do you need the other party to like have the other key and to like on the website, there's an example of a painting. That's what I'm going off of.
So, I didn't understand your question actually.
So basically, if I'm digitally registering, let's say I bought the Mona Lisa, and I'm going to digitally register with your protocol. Well, actually, let's say I didn't buy it, but I just digitally registered that I did. Like, you know, how does that determine fraudulent?
So the real owner or the real creator will come in and challenge your basically, or anybody who is affiliated with them or supporting the truth over here will be coming in and challenging your the claim, and then there will be you will be kicked out of the TCR because you are not playing fair. You are putting something false on this. So there will always be.
Do you think so? It's like a long project where it's like it's the goal is to become like widely adopted, so that
yes,
you know.
Yeah, absolutely.
How long do you think that would be, like a decade or so? Or?
I wouldn't comment on that because every TCR in itself will have value for a specific community. Like the ad chain TCR, which Mike and their team has created, is specific to publishers and people who want to put their ads on these publishers. A TCR that we created for data governance with one of our customers is primarily focused on how organizations can contribute towards defining processes. So it is always which kind of community you are targeting and what exactly your TCR is bringing in terms of value, the contents, and then it also the real problem here is bootstrapping, that how well your TCR is bootstrapped. For example, if you already do not have any values, it does not have any value. It is a catch-22 problem that the TCR has no content, there is no value, so nobody will be coming in and putting their applications. But if it has some good content already, then people will be coming in and putting applications, and there will be more demand of the tokens. So bootstrapping is definitely an issue, but after that, it really depends upon how much value the TCR is providing to particular target community.
One more question. How do you think it differs or is similar to Factom? How would you say it's different or similar to a project like Factom?
I haven't heard of them actually.
Okay.
Yeah. Sorry.
Another more specific question about. So you mentioned the TCR needs to have its own key, right? So it can receive tokens and then distribute them when the rewards are given out. So somebody who initializes the system has the private key for that.
Just in case of when we are implementing it here, like I mentioned, if you are implementing it on Ethereum network, then the smart contract is actually governing it based on logic. There is no private key for a smart contract.
Okay.
But just in this case, because we do not have smart contracts, we'll have to live with a centralized owner of the TCR.
It seems like a smart contract is kind of necessary then in order to actually get one of these things into production, right?
If you are doing a full permissionless deployment of this, definitely it is necessary, because you want the results to be driven by logic and not by someone. Right. But if you are doing a deployment inside an organization for game theoretical perspective, or like this data governance use case that I mentioned, then this should be fine. Like if you are hosting it at a trustworthy source, then you are good to go. Yeah.
Can you briefly explain again how, let's say a proposal is to be challenged, how the vote is calculated? In particular, what's the cutoff point? Is it a 50-50 vote, or is it the majority of tokens? How exactly do you calculate whether the...
So the total amount of stake put behind the proposal versus the total amount of stake put behind the challenge. So the total amount of stake is calculated by the stake put behind the proposal plus the stake put behind each and every vote which is supporting the proposal. So if I go back to my calculation function over here, so over here, like when I get all the votes, I see the votes are against the proposal, and I actually put them in a separate place and create a value out of adding all those stake when they are against, and I create a value by adding all the stake which is for the proposal, and then I simply say greater than or equal to. Equal to is there for benefit of doubt.
Okay, so there's basically one sort of point at which it is decided, which could be just decided by one unit, one way or the other.
Yes.
Okay, from a game theoretic point of view, that often tends to create very unstable equilibria if it's sort of gameable around one cutoff point, right?
In ideal situations, these are blind votes actually. You do not know what's happening.
Okay.
So you cannot sway it until some of these are revealed which direction things are flowing. I mean, in this case, these are going in plain text, but when I'm doing a proper deployment, I will be basically encrypting all these votes.
I guess that alleviates the problem.
Some sort of it. I mean, again, the question goes back to the point that I'm sorry, I don't remember your name, but yeah, but he raised that when people are colluding, then this becomes a similar problem, that people are basically knowing which way things are flowing, and then they can put more stake and get this thing in that direction. But until you are not colluding, then votes are all blind, and this can be avoided. Okay, any more questions? Cool. Thank you so much.